All right. Thank you, everyone, for being here, for attending this talk about refactoring legacy applications the right way. We have a full house. It's nice to see, well, no empty chairs. There we go. Problem solved. Before I talk about refactoring, I want to take you along on a story. I want to take you along in my time machine to 10 years ago. So we hop on time machine and we go to 10 years ago and we work at a company, let's call it XYZ, and we have an intern named Josh. Let's just call him Josh. Josh is a young guy. He's in his last year in higher education. He has that twinkle in his eyes. He's very motivated. He's smart. He's clever. And we have a problem at our company. It's a simple problem, right? And Josh is looking for an internship for 2 months. And Josh is going to solve that problem in 2 months, and he's going to write us a program in 2 months that solves it. And the world is going to be better for it. And that's what happens, right? Josh takes 2 months, writes a little application, automates the process, and everybody's really happy. Sounds good, right? Excellent start to a story. Let's hop again in our time machine to 5 years ago. So now 5 years ago, our situation has changed a little bit. Our application that was once used by maybe 1 or 2 people and wasn't very essential is now become very essential for our company. More and more users, more and more features are getting added to the application. And well, let's just say George is probably not around anymore because, let's be honest, in IT, most people don't stick around for 5 years. We tend to job hop a bit. But anyway, let's say we have a team of 2 or 3 developers supporting the application, and it's getting a bit busy, right? But we're going forward. We don't have time to think about things like structure of our code. We need to add more features, right? And we also don't have time to look at our old code and maybe make it a bit better. And if we don't have time for those 2 previous things, well, we obviously don't have time for automated testing. That would be ridiculous, right? We hop back in our time machine and we go to 1 year ago. Our code base now looks a little like this. Looks really advanced, right? But it's, I don't know. I can see a bit of duct tape here and there. And the wires, well, I'm afraid if I walk past it, then I might disconnect something and the whole thing goes down. And our application it's getting more advanced. It's doing more and more stuff, right? Which is good. More features, more users, because right now we're 9 years in the future from Josh, right? Josh already is a senior developer now, probably. Depends on your definition, of course. But it comes down to the fact that we have more users. Our company has grown, probably over 9 years. And our application has become more essential. Even more essential. If it goes down, we are in big trouble. But we're starting to notice something is very, very wrong. Things are going to go slower. Things are starting to go slower. Development specifically. Adding some text field that used to take an hour now takes a day. We are starting to have downtime, more bugs. I like to talk this morning in the keynote because it was really relevant to what I'm going to tell you today. And it's getting harder to onboard new people. That's something that we always forget. It's getting harder to onboard new people because our code base is getting a bit harder to understand. And maybe we used convention A over there and convention B over there because communication wasn't that great. It's possible. And change is getting harder. We can't change. Because if we change our code, we're going to create bugs. Don't want bugs. And we can't write tests, obviously. Well, we didn't have time before, but now we have a better excuse. There's too many dependencies. It's just not possible anymore. And then we hop in our time machine for the last time, and we move on to today, the present. And this is what our code base looks like now. And anyone who sees this image and has worked in a legacy code base will feel it in their soul, right? Our fellow infrastructure IT people deal with this every day as well on an Physical level, we deal with it on a code level. Downtime is no longer something special. It's weekly. Yeah? It just happens. It's part of life. But due to that, we have a non-stop stream of support tickets. Very fun. We all love doing support. And if you're lucky, you can do second line or even third line. If you're unlucky, you might do first line. And obviously, because you need to do support, you have less time. And less time means we don't have time to do unit testing or any type of automated testing. It's also, again, harder to onboard people. It's even hard to find people because I'm willing to bet that a lot of you can name one or two, at least, companies that you're not willing to work for because you know their code base is this. And word spread fast. Community of developers, don't go work there. It's not that great. Not only that, if you finally find someone, we find a junior who hasn't heard about our company before, that unwitting soul, that poor guy, or girl, obviously, they run away after a year. Your code base has now officially become an HR problem. Yeah. I'm not joking. This is a good one because, as we all know, we all face some pressure from business. This is a good one to take to them. HR problem, my code base, that's something they know. So basically, we have too much work and we can't save this anymore. And we can't change anything again because we get bugs. And our once so simple, beautiful application that Josh made, can't we go back in time, has crashed basically. It's on live support, it's blocked, and we can't see the forest for the trees anymore. What shall we do now? Does anyone recognize this? Yeah, no, nobody does, obviously. No, it's a very unique situation that I've only found myself in. No, that's certainly not the case. I've made my career on working on code bases like this and bringing them back to life. How do I do this? Obviously, there's only one solution. Let's go back to Greenfield. Let's do a rewrite. Look at how happy this guy is. And look at how healthy the cow is. This sounds like a great idea. What could be wrong with going for Greenfield? Let's write our application all over again because we already know all the problems. We already know what went wrong. We won't make the same mistakes again, will we? And obviously, we already know our entire domain right now, so nothing's going to change. Look at how green the grass is, the fresh mountain air. That's something we don't have in Belgium. You have it probably here in Sweden, but we're flat as a billiard table. Can I ask, this may be a sensitive question, but who here has suggested doing a rewrite? I see a lot of people. Who here has regretted suggesting a rewrite? Can I ask that? A few hands. Not so many. Okay, good. So a rewrite can be a good idea, but you need to take a few things into account. First of all, there's double the development work right now. You already said you don't have time. How are you going to do double the development work? Because you still need to support your old application, and business wants you to deliver value, wants you to deliver features to the customers, which means you need to implement it in both systems. Because your rewrite is somewhere in the background, which is also not a great thing, of course, having your rewrite work on it for 6 months in a black box and then release it in one big bang. Maybe don't do that. And so everything goes even slower. And most of all, it's getting... Ooh, that's bright. Oh, and now my screen is gone. Something weird happened. Yeah, it's a rewrite, yeah. Maybe I can turn the TV around because you can see it may be a bit hard to read. Yeah. What could go wrong? Yeah. Okay, fine. So what I said is double the development work. We need to keep supporting the old application. Everything goes even slower. But all of the above, all the things I just said, are very expensive. How are you going to convince me? In this case, pretend I'm a business person. How are you going to convince me that I will give you the money that you need to do this refactoring? it's going to be hard. And if you finally do manage to sell it, then I can tell you that expectations are going to be high. And pressure will be high as well. Now, chances are that you probably didn't learn anything from your previous session of writing that application. And you're going to deliver a second legacy application, but just a bit smaller. Have a great visual here, but you can't see it that well. So the thing is, if you do the same thing, obviously again and again with the same result, what is that? The definition of insanity, I think? Something like that. In Dutch, we say, een ezel stoot zich geen twee keer aan dezelfde steen. A donkey doesn't hit the same stone twice. If you do, then maybe you're the donkey. Supposed to be smart animals, but we use them to say not so smart. Now is the question, of course, can we still fix this? I think a lot of people who are in a legacy system don't know how to get out of it. And desperation kind of sets in. And what's the only solution then? Quitting your job, basically. It's a quick fix. It's not the best fix. Let's be honest. Don't quit your job. Maybe a short introduction who I am. My name is Niels Stubbe. I'm an application architect at Encore. There we go. Just in time to show my mugshot. And it's a small boutique, maybe you say, consultancy company located in the west of Flanders in Belgium. And we focus a lot on modernizing applications. I write a bit of blog posts. You can find them at codecrash.net, or you can follow me on LinkedIn. But enough about me. Let's get back to interesting stuff. So what is legacy code? I want to talk to you about first, what is legacy code? I want to talk to you about what is refactoring, and then how are we going to refactor? Because it's more about learning from your mistakes than actually a specific approach. I think this cartoon is really great. It's from the first coding book I ever read, and it's called Clean Code by Robert C. Martin. I'm going to assume a lot of people have read it. There's a bit of mixed feelings sometimes about the book, but a lot of it is very worthwhile, especially for a junior developer, which I was at that time. And I really like this comment. So let's just say legacy code. When we say that, what do we all think? We think of bad code, right? It's basically the same thing. So what's the difference between good code and bad code? Well, good code has a smaller number of WTFs per minute than bad code. Simple as that, right? When you start on a new code base, you're always going to be confused and you're going to say, what the hell did they do here? But after some time, you learn the conventions, you talk with your teammates, and things start to make sense. I've worked on a lot of code bases since I'm a consultant. Every time I hit a new code base, I think, what did they do here, right? But after some time, I start to notice that there's reason to the madness. If you have bad code, there's no reason to the madness, and you, for example, have different conventions. Somebody's using domain-driven. Somebody's using service layers, and they're all mixing together. That's usually not a great thing. When I gave this talk the first time, I asked using Menti. We all saw it this morning in the keynote as well again. I asked the people I was giving the talk to, all right, what to you is legacy code? And well, there's a bit of Dutch in there because it was for a Dutch-speaking crowd. But there's a whole bunch of interesting things there. And what do I agree with? There's no room for easy changes, somebody said. No one likes to touch it. It's difficult to understand. And again, difficult to make changes. What do I disagree with is old code. And that's a problem with the word legacy code, I think. We automatically think it's old code. Old code is not necessarily bad code. However, old code has had more time to become bad code. And that's why old code frequently is bad code. But it's not necessarily a one-to-one. You can be certain of it. Somebody also said it doesn't read like a book. That doesn't necessarily mean it's bad code, but I have to be honest, personally, when I code, I like it to be able to read my code really easily. Clarity over cleverness. What I definitely don't agree with is somebody wrote here, it's in Dutch though, that code written by somebody else. I would hope that you have a team with conventions and that you do pull requests and code reviews. Then you wouldn't have to write that. Obviously, the person writing it did write it kind of as a joke, but I've heard it said by people in a serious way. Also, code from yesterday. Code from yesterday, I'm sorry, if you think your code from yesterday is legacy code, then you need to take a long, hard look in the mirror. And lastly, but not least, a really, really interesting one is downward spiral career. I can understand that sentiment, but at the same time, I've built my career on top of legacy code, so maybe I'm a bit of the exception. So there's a whole bunch of different things that people say is legacy code. It can be old code. It can be untested code. That I kind of agree with that one more, right? Old code that has tests is usually a lot better than any code that you wrote yesterday that's untested. It can be deprecated libraries or frameworks, or it can be undocumented code. But again, I'm not feeling it. Deprecated libraries or frameworks, okay, fine. But if an application works and it's easy to work with and it does what it needs to do and it's secure, that's a big one, obviously, why should we need to change it? Sometimes systems are so essential that it's better to keep your hands off it. But obviously, you need to know what happens in it. Huh? Undocumented code, also, not every piece of code needs to be documented. Too much documentation is also not a good thing. So I suggest the following to you. What is legacy code? Simple. It's code that you're afraid to change. You don't want to touch it, because if you do, it becomes your responsibility. Because it breaks easily. You have no idea what it does exactly, and there are absolutely no tests to tell you if you broke something. And if there are tests, they are probably commented out. But not everything is legacy, and this is something to keep in mind. We overestimate the complexity of unfamiliar code. If you're working on a code base that you just started on, it's probably going to feel like it's not a great experience. But that's because you still need to learn. Every time you enter a new code base, you need to learn what the people were thinking that worked on it. Documentation, of course, and testing, which is also, honestly, a bit of documentation, can help a lot with that. It usually gets better after a few months. And like I said, old code or tech can be good. It doesn't mean because it's old that it's automatically bad. So that's what legacy code is. Code that we're afraid to change. But what is refactoring then? Well, there are 4 reasons to change code. We can add a feature, we can fix bugs, we can improve design, and we can optimize performance. Adding a feature, very simple. Adding a new text field, making sure on submit that it's saved to the database. Fixing a bug, oh, that text field isn't correctly saved to the database, I'm just gonna fix it. Those 2 things, you're changing behavior. Your end user or any external system that communicates with your system is your system responds differently to it, right? Improving design, that's all about basically for yourself. You're doing work refactoring for yourself. You're changing, for example, the architecture of your application. You're making things a bit clearer, making functions a bit clearer. It helps you to work on the code, makes it more decoupled or anything like that. And optimizing performance, making your code faster, making it more efficient, especially that last one is really important nowadays with cloud being everywhere and your code not being efficient may cost you quite a bit of money. So those are the 4 reasons we change code. But what is refactoring then? Well, refactoring is the process of restructuring code while not changing its original functionality. Its goal is to improve your code by making many small, very important, small changes. That's something that we all go against. We make big changes and then we break. Let's just say we hit a roadblock. We make small changes instead without altering the code's external behavior. What that means is that adding a feature and fixing bugs is not refactoring. And if you're trying to refactor, don't mix. You do not want to have a feature that you're developing and mix it with refactoring. No. What you're much better off is adding the feature in the old existing code, making that commit, pushing it, making a pull request, and once it's merged, then you can look at refactoring, not before. Or the other way around, but first refactor and only then add the feature. Although I have to say, that second one usually gets you in hot water. But why do we need to refactor? So again, my situation, I have a system with a lot of technical debt and I don't see a way to fix it all. I want to rewrite the entire application from scratch because that's a great idea. Let me equate it to something else. Let's say you have a restaurant, right? And it's open for 6 months. You're doing business, it's going great. You have a lot of clients that love your food and your terrace looks really nice. Your interface looks really nice. But on the other hand, we can't see what's happening in the kitchen. And you're not that great at cleaning up and keeping things up to standards. And suddenly you get these guys. And they're crawling all over your kitchen. And one day, you get a visit from the health inspector. And they tell you, this needs to stop. You need to shut down. You need to clean this place up. And then you need to call these guys. So what happens? You need to close everything down. You call those guys. They clean everything up. Meanwhile, your clients might have seen their van on the outside of your restaurant. And there goes your reputation. But, okay, you close for 2 months. And suddenly, we're back to this situation. That's great. What have you learned? That you need to do your cleaning and you need to maintain your kitchen. But do we? Usually we don't. And we end up in this situation again. This is why I said rewrites aren't usually a great idea. Because what happens, instead of changing your existing code base and trying to make a commitment to fixing that, you just move the problem elsewhere. And greenfield is easy, and greenfield is fun. I get it. But refactoring is a lot of hard work, just like cleaning a kitchen and keeping it maintained. But you have to do something to make sure that you don't end up in the same situation again and again and again. And that's why something to think about is the cost of your technical debt, right? The cost of change to add a feature, for example, to your code base is going to go up either way, the more complex and the bigger your code base gets. That's normal. That's perfectly normal. But the big difference is the more technical debt you have, the bigger that cost of change gets. Like I said, if you have a legacy application without unit tests, without anything, you're afraid of it, you're afraid to break things, adding that field will not take a day, will not take an hour. It's going to take a day, 2 days. I've worked on an application where it took me 3 days to add a stupid field to a form to submit to the database. But that was pretty crazy because it had configuration in the database and all things like that. It was really sensitive and not that great. So what we can tell from this is that it's very important to continuously keep refactoring and cleaning your kitchen, because the cost of making changes will increase dramatically. And again, the refactoring cost is a very, very tiny fraction of this. Cleaning your kitchen every day doesn't take a long time. Cleaning it once every 6 months, well, you need to pay somebody else to get rid of the bugs, right? Usually, they pay me to do that. So I'm the guy with the spray thing. But usually I hope I don't have to come back. This is another one. If you want to show something to management, to business, show this one, right? So software development, as it is very expensive. Never refactoring just makes it more expensive. So there's a whole bunch of causes for technical debt. And the first one that we all know is business pressure. Right? We need more features. We need to go now. You don't have time to refactor. Refactoring is an ugly word. It has a very nasty connotation for a lot of business people. I personally don't use it. I say, oh, we need to rework that, or we need to polish it a bit. Refactoring is a dangerous word. A lot of times, somebody before you has said, let's refactor. And what do? They combine the feature delivery with refactoring. And that feature that needed to be delivered 2 days ago is now stuck because they're working on the refactoring. And they say that to business. And the end is, refactoring, that slows things down. So it's a bit of a psychological effect as well. You want to keep those things separate. But there's a whole bunch of other reasons, of course. The lack of understanding of technical debt. What's going to happen? Like this. This is something to explain. We need to communicate to our non-technical stakeholders, guys and girls, this is a problem. It's going to cost us more money over time. Lack of tests, I've already said it, but tests are important. If you like it or not, tests are very important to increase the quality of your code. You can't move around it. If you don't have tests, hopefully you have a very small, simple application, or otherwise, you're going to feel it. Lack of documentation is another one. Pretty simple, straightforward. Lack of interaction between team members, that came, and the keynote this morning, it was very clear that's also something, the forest between the deserts. Well, it's very important to communicate with each other. Everyone doing their own thing is just going to create a terrible experience for everyone. Long-term simultaneous development in several branches, long-lived feature branches, a terrible idea. Especially if you're trying to refactor, because maybe I've refactored something and it's a lot easier to work with, but you have a feature branch that's been, I can use no other word than rotting for 6 months, and now you want to merge it. We're going to have a lot of fun, you and I. Huh? Delayed refactoring. Again, referring to the graph before. Lack of compliance monitoring. What's compliance monitoring? Well, you could do automated monitoring, checking your code for quality, but even just pull requests and code reviews is a form of compliance monitoring. You don't need to look for it too far. Lack of knowledge is the last one, and this one is really important because there's I forgot what it was. There's one of those razor laws, and it's don't attribute to malice what can be attributed to something, lack of knowledge. Basically, if you have people that you feel are generating legacy code, maybe they just don't know any better. And again, what's the key to that? Communication, helping them realize their potential, right? Helping your colleagues. Now, we all attribute things to business pressure when we write legacy code and we don't refactor. But at the same time, business pressure is maybe the only thing that we don't have a hand in. All the other things we can influence. And even business pressure is possible to influence, but you don't have that much of an impact on it. But all these cases of technical debt, they're in your hands. And that's a bit of the point of the talk today as well. It's not fun. It's hard work, but the only thing you can do is put yourself to it and refactor. There's no magic way to refactor and make your code base better. You're going to have to do it, and it's a bit like cleaning your kitchen again. Because refactoring each day keeps the rewrite away. You want to refactor at fixed moments. If you're not refactoring right now and you don't know how to start or you feel overwhelmed, well, refactoring, I compare it to a muscle. If you go to the gym for the first time, it's gonna suck. If you go every week twice, you're gonna get better at it. That's the same with everything. That's the same with playing guitar. It's the same with, well, programming as well, with any skill that you need to learn. It's a muscle, it's a skill that you need to develop. But to get started, don't start with, I'm gonna take the biggest problem on in my entire code base and I'm gonna refactor it now. That's gonna take 2 weeks, and you're gonna regret it. Because chances are that you're gonna end up with something that's not really valuable. Instead, start simple, time box it. If you don't have time to refactor, I say to you, what about half an hour, 2 times a week? Is anybody gonna notice an hour in total every week of your time just going to simple refactoring? The answer is no. Nobody's gonna notice that, right? And this might sound a bit sneaky, but that's what you have to do with refactoring sometimes. You don't need to specifically mention it to business people as such. You are keeping the quality of your code high. You're creating a situation where you are more productive. It's a win for them, but sometimes it's a lack of knowledge and understanding that holds you back. And it's good to communicate, but it's not good to over-communicate. I know this sounds a bit sneaky, but it really isn't. Yeah. We'll come to that in a second. I promise. We'll answer that. But to get started, I ask of you, just take half an hour twice a week, maybe just even half an hour once a week, and just start and learn how to refactor. It's a skill in itself, and if you develop it more over time, you're going to get better at it. And I also say, write down a list of things you want to improve. Pick one, pick the smallest thing. Don't pick the biggest thing. And there you have the power of tiny gains. I really like this one. If you take something and make it 1% better every day or even every week, it's not much, but over time you will notice a very big change. Now, when you should refactor? Well, simple, after writing a test. First you write a test, then you refactor. Is this always viable? No, but we'll come back to that. But if you use TDD, for example, I personally don't use TDD religiously, but I sometimes use it. But you can use the same logic even if we're not working with TDD. You have a piece of code, you write a small test for it, and then you refactor it. You're 100% sure, well, 99% sure, a bit less maybe, depending on how good your tests are, that it will still work after you refactor. So that's a good time after you've written a test to refactor. Now, if your design is causing you pain, it's called pain-driven development. It sounds silly, but it is. Don't start with the thing that is most complex or that is most used in your application. Start with the thing that you touch the most, that you work the most in, that you spend the most hours on, that you feel the most pain on, and fix that first. Make your own job. Refactoring is literally the act of making your own job nicer. As part of fixing a bug, before I said don't mix bug fixing and refactoring. There's one exception, and that is when you clearly see that the design of your application or whatever has caused the bug. So if you see like my application, my code is designed in such a way that the bug came into existence, that's a good thing to refactor. And then finally, obviously, the best way is before the technical debt gets into your code base, and that's code reviews. Just stop it right there, review the code of each other, and stop the technical debt from being added to your system. Now, very important, when not to refactor, never refactor a broken system. If your code doesn't work, don't refactor. Fix it first. Do not mix the two. Otherwise, you will have somebody breathing down your neck. When is it fixed? When is it fixed? When is it fixed? And you're going to give yourself more stress, which results in even worse refactoring. Massive technical debt is the second one. That's the exception, but that's when you have technical bankruptcy, you have so much technical debt, you can't get out of it anymore. Well, then maybe it's time for a rewrite. I've only encountered that once or twice. And imminent deadlines. Because when should you not refactor? From Martin Fowler, from his book Refactoring, Improving the Design of Existing Code. You shouldn't refactor close to a deadline, but saying, I don't have enough time, is usually a sign that you need to do some refactoring. Like the guys in the first example, we don't have enough time to do this. If you don't have enough time, you need to refactor, because refactoring makes more time. It's an investment in the future. Okay, so refactoring your code, that was when and why you should refactor your code. But how do you refactor your code while avoiding headaches? Well, there's two ways. You can test first or you can refactor first. Without tests, you don't know if things are broken. You need to manually test, which takes a lot longer. And you're going to test less, making development slower. Right? You're going to write more code before you test, and then it's going to take a longer time. So step one is to write tests. Unit tests, people always focus on writing unit tests. Stop. It's hard to write unit tests in an existing system. You should focus on writing high-level integration tests. Just write integration tests, test the HTTP calls of your system if it's an HTTP API, test the database maybe. If you do that call, check if the data is correctly saved in the database. And test calls to external interfaces if you have integrations. Just start with that. That's enough. You don't need to write entire unit test suites. Because if you write unit test suites, you're going to get blocked on dependencies and how to use those dependencies in your test, etc., etc. If your code is not developed with tests in mind, you're going to get stuck. Integration tests don't have that problem usually. Step two is refactoring. Hooray. Now we can quickly test thanks to our automation, and we are less likely to introduce bugs because we've got our tests to stop us from introducing those. And then the third step is improving the tests. You quickly write those tests. They can be a bit slow and flaky. Integration tests aren't always the best for every situation. They are pretty great, but still. You can write unit tests if applicable, because now you're free to refactor your entire code base because you've covered it in tests. And finally, write more tests. Maybe you can see where I'm going. But there's also, sometimes it's a large thing to get over, writing all those tests first, and people stop there. People get blocked on the first step. I need to write all those tests, and they never get farther than that. And sometimes it's better to refactor than to not refactor. And if that's stopping you, then just refactor first. It's not as safe as the recommended approach, writing tests first, but it will be faster. And then you can do some safe refactoring, for example. You only perform low-risk changes. You rename some symbols, you extract functions, you align variables, and you try to separate your infrastructure and domain. These can be simple changes that have an enormous impact on your code base and can make your code more testable. We've refactored first, but we still need to write tests. Sorry, you're still going to have to write tests. But we can write approval tests. And approval tests are a bit of a dumb version of an integration test. In the previous example, what we did, integration test, we know what the expected behavior is. For approval tests, we don't care what the expected behavior is. We write the test. If it fails, it will tell us what the behavior is. And then we change our test. We copy the test and we change a few things. And then we see what the expected behavior is there. What do we get? And we test all those inputs and outputs, just like we're testing a black box system. And we repeat that over and over again. And that's a lot faster to test. It's a bit dirty though. But it can help you. And it's a lot easier than having to go to business, asking what the business demands are and what we need. You can just test the code as is. But testing the code as is means that any bugs that are existent in the code will also be included. Something to use is lots of systems have code coverage tools. You can check which lines of code are tested and untested. Just write tests to that instead. So there's two approaches, test first and refactor first. Test first is the safest approach. It's great for critical features. If you have a payment module, please use this. Takes quite some time though, and tests could be slow and flaky, and you'll have to do step 3, so write more tests and refactor your tests to be in the sweet spot. But refactor first is a lot more faster, bit more risk. You need to make changes more carefully, and it's good for less critical features. So which one should you use? Well, simple enough, just get started. It's all about what works for you and your team. That's all that matters. So be pragmatic. Just stop the bleeding. Put a band-aid on it. And that's where you get started. Again, the power of tiny gains. Now, all this is good and well, but how still do we move on from this situation? Well, I already had this before the keynote this morning, so we use the same analogies apparently. We can go to the forest, we can use a Strangler pattern. Now, for those who haven't heard of a Strangler pattern, what you basically do is, it comes from a Strangler vine. You have a tree, and the plant, the vine, wraps itself around the tree and eventually, well, it's a bit grisly, but sucks the life out of the tree until the tree is gone. But there's the Strangler fig still stands there, right? That's what we can do with our application. We start with our legacy application and we put a facade in front of it. For our external users, people who call our application, nothing changes. But behind the screens, we create a second application, our more modern application that follows best practices and that we refactor. Very important. And over time, what we do is we port bit by bit to our modern application. And after some time, although this is a bit of a utopia, I'm going to be honest, you end up here. Usually, what happens is the following. You get this situation. We move a bit. Good job, good job. Oh God. We moved back a bit. We needed to develop a feature in our old code base again. But eventually you end up here. And if you're very lucky, the last bit disappears, but a lot of the time you have dependency on older systems or all the libraries that you can't get from Android. What is the power of this thing, of this approach, is that you can add new features. You can add new features to your new application without having to add it to your old application, because they're the same thing to the outside world. What happens behind the screen, behind that facade, nobody knows. Okay? So you're free to do whatever you want. How do you set up that facade? Well, very simply, you need a reverse proxy. You put that reverse proxy between your public internet and a private network, and you route to the right endpoint. This example is more API oriented, but I've done it with front ends as well. It's perfectly viable. So, quick recap to end with. When refactoring, don't change external behavior. Don't combine fixing bugs and adding features with refactoring. You have to refactor continuously. There's no other way about it. It's hard work and you need to do it. Refactor in small batches. Save yourself the headache. Don't refactor when there's deadlines coming up. First, fix or add the feature for the deadline. Maybe take on some technical debt, but do it willingly and do it consciously and fix the technical debt afterwards. Only refactor working code, write tests, but don't focus on unit tests. It's not necessary. And consider using Strangler pattern. Now, with all this said and done, if you would like to know more, I can recommend 2 great books. They're honestly amazing books. Working effectively with legacy code and refactoring, improving the design of existing code. Both amazing. You can find them on Amazon. And that's it for me. Thank you very much for listening. I hope you enjoyed the talk.